again we are solving question number 8 from the exercise, right? So 3 vessels of equal capacity. I am waiting for a few of you to tell me what is capacity. Yes, very good, it is volume. Well done. So 3 vessels have equal volume, so we are given that the volume is same, right? Have gases at the same temperature and pressure. Are wow, badhu same, volume same, temperature same, pressure same. The first vessel contains neon, which is monoatomic. Okay, first one contains neon, second one contains chlorine, that is Cl2 diatomic gas. The third one contains uranium hexafluoride. I am sure you have studied this in chemistry. Okay, so uranium hexafluoride. Okay, so that's a polyatomic. Again, polyatomic means something that has more than one atom, right? But typically we use it for 3 or more, right? Okay, so do the vessels, remember volume same, pressure same, temperature also same for all the 3 vessels, right? I hope you got that. Then do the vessels contain equal number of molecules? It's lagging, I know, it shows that there is unstable connection. Okay, now is it clear? Is the voice and video everything okay? Alright, yes, I will repeat. So the question is, do the vessels contain equal number of molecules? Moles nahi, molecules which was it? That is, the question is N same? Right? The question is N the same for all the 3 gases? Right? So how to find N? Can you think of a relation that is with VPT and N? Can you think of some formula where you have N, that is number of molecules? May not be direct, could possible indirectly in 2 or 3 steps, if you can get to that. Yes, first of all we should use ideal gas equation. Yes, so this will tell you that because P is same, V is same, R is a constant and T is same, so mu is also same. Okay. Yes, Ria, you can do it like that. Rushabh, you can do it like that, no problem. So if mu is same, then N will also be same, because N is equal to mu into Na. Okay, clear? N will also be same, right? Understood? Okay, moles are same, so number of molecules also same. Right, now you know it's just like a comparison between 1 dozen of apples and 1 dozen of oranges. Both are 12. Okay, so next, is the root mean square speed, means is Vrms same for all? What is the formula of Vrms? Hopefully everyone remembers. What is Vrms? Everyone, what is Vrms? What is the formula of Vrms? Can you hear me, everyone? Okay, don't worry, I just had to switch connections because I had to switch connections because there was some problem with school's internet. Now can you hear me clearly? Okay, well, fine. So hopefully now once again you can see the screen. Okay, let's continue. So I was saying that I want to know what's the formula of Vrms. I don't know whether you have typed it there. Yeah, Vrms. We want to find whether Vrms is same or not. Can you please tell me what's the formula? That's right, Risha. Others, hurry up. Rohan, are you sure? ખાલી KBT by M થોડું છે. It is root 3 KBT by M, right? Or you can also use, again I prefer this one, under root 3 RT by M0, right? બેથી same as result આવે. Again, don't worry about that. I prefer this second one. Okay, so is it same for all? Is it same for all the three gases? What is same? Have a look. 3 same, yes. R same, yes. Temperature also same, but molar mass not same. Okay, molar mass is not same. So in which case is Vrms largest? In which case is Vrms the largest? Think about it. Look at this. M0 is in denominator. M0 is in denominator. So to make Vrms largest, molar mass should be smallest. Yes. So molar mass smallest in neon, of course, right? Because neon's molar mass is only what? 16, isn't it? 20 है कि 16? 20 આવે, sorry. 16 तो oxygen નું છે. You are right. Okay. Chlorine is about what? 79 કે એવું કંઈક હતું ને, 79 or 80. Cl2 છે 35.5 નો આવે, 70. Okay, like that. And UF6, just 1 minute, the page got changed by a shortcut. Yeah, and UF6 is much more. Uranium નું 238 હોય અને fluorine નું 17 હોય ને. So 17 into 6, so it's much more, right? So either bhuli jao. So that's why the answer is neon will have largest Vrms. Okay, I'm sure everyone got that. Right? So that's it for this particular question. Okay, now we go over to talking about more specifically about thermodynamics, right? Yeah. Now in thermodynamics part of this chapter, we're going to talk about processes and this and that much more than we normally do in kinetic theory of gases, where it's all about the gases, the laws and Vrms and all that. Okay, now we're going to start with basics. A lot of basics you have studied in chemistry, so I'm not going to take a lot of time to go through it. Okay, so first of all, system, right? What we observe or what we are studying or observing is called system, right? And what are surroundings? Everything except system. Everything except system is surroundings, right? Okay, the whole universe except the system is surrounding. Things have boundaries. Okay, something that separates system from surrounding. I'm not even writing that, it's very easy to understand. Boundary may be real, boundary may be imaginary. Okay, it's of no importance. Sometimes boundaries, when they are real, okay, boundaries, if they are real, we call them walls. Have you come across this word in chemistry? Walls of a system or walls of a vessel. Okay, પણ સમજ તો પડી ગઈ ને walls શું હોય, right? Walls are real boundaries of a system. For example, walls of a closed vessel or walls of a room or something like that. Okay, next, the next thing is types of system. Okay, the next thing is about types of system, right? Open system, closed system, and number 3, isolated system. બધું આવડે જ ને? હા, સરસ. Open is where mass and energy, where matter and energy both can cross boundary, right? That is called open system. Yes, can be transferred between system and surrounding, or in simple way you can say they can cross the boundary, right? Easy way to say, right? Transferred between system and surrounding. હા, બસ તો એ જોઈએ જ દિયા, એવું 2-3 જણ કહી દે એટલે હમણાં હું ભગાવું. ઓકે, closed means energy can be transferred but not mass. Energy change is એવું કહેવા કરતા, it's easier to say that energy but not mass can be transferred or sent across the boundary, right? Okay, what you are saying is still right. Okay, energy change, saying that energy changes is another way of saying it. Okay, right? The third one is isolated. Isolated where neither energy nor mass can be transferred. Okay, yeah, right? Okay, fine. So these are some of the basic things of a system. Now let's go to the next thing, types of walls. Have you studied this in chemistry? અરે વાહ, એ આવડે છે, બહુ સરસ. Some of you are saying no, some of you are saying yes. Life is so confusing. Black hole is an open system. Okay, black hole is an open system. I know that will raise many brows. Okay, black hole is not an isolated system. Black hole is not an isolated system. Black hole is open system. Okay, so what are types of walls? Number 1, diathermic. सीधी भाषाમાં conducting. Okay, diathermic or conducting. Second one, opposite, non-conducting. And non-conducting means insulating. Is this okay? Right? And such walls are called adiabatic. રાઈટ? હા, બધું આવડે છે, બરાબર. ફોર્મમાં રહેજો છેક સુધી અને યાદ રાખીને રહેજો. ઓકે, સો diathermic is where heat can be transferred through the wall. જો ચેપ્ટર આવ્યો heat transfer, right? Heat can be transferred through the wall. અને આ એનું ઓપોઝિટ, heat cannot be transferred. Through the wall. ઓકે, આજ કેમ પબ્લિક ઓછી થઈ ગઈ? કોરોના થઈ ગયો બધાને કે ઊંઘ આવતી હતી? 4 વાગ્યામાં કોણ આવે? એવું છે? ચલો કઈ વાંધો નહીં. થર્મોડાયનેમિક્સમાં જેટલા ઓછા એટલું સારું ને, મારે કંઈ બહુ ટેન્શન લેવાની જરૂર નહીં. પેપર છે ને આજે? અચ્છા, સવારથી પેપર જ લખે છે? બહુ લખ્યું પેપર તો. ઓકે, લેટ્સ સી. પોસિબલ, મસ્ટ હેવ ફોરગોટન ચેન્જ ઓફ ટાઈમ. ચલો વાંધો નહીં. ઓકે, નો પ્રોબ્લેમ નંદિની, એવું તો થાય, રાઈટ? આઈ એમ ગ્લેડ દેટ આઈ કુડ મેક ઇટ ઓન ટાઈમ. Okay, next thing. So these are type of walls. Now properties. Okay, there are two types. આ તમારી કેમેસ્ટ્રીમાં આવે છે, ઇન્ટ્રિન્સિક એન્ડ એક્સટ્રિન્સિક. આવે છે ને કે નથી આવતું? ઇન્ટ્રિન્સિક એન્ડ એક્સટ્રિન્સિક. Intrinsic means property of material or substance and does not depend on mass and does not depend on quantity. You can say does not depend on quantity, right? Okay, property of material or substance and does not depend on quantity. આ ચાલે. આ તમારે ઇન્ટેન્સિવ અને એક્સટેન્સિવ એવી રીતે આવે છે કેમેસ્ટ્રીમાં. હા, એ જ બેઝિકલી ઇન્ટ્રિન્સિકનો મિનિંગ છે ને એવું થાય ઇન્ટરનલી. યુ સી, ઇન્ટ્રિન્સિક means something that is internal for that substance. Okay, આ બીજું તો તમને આવડી ગયું. Depends on quantity. Okay, ચલો. So these are some properties of the system or whatever it is, right? Surroundings માટે ચાલે. હા પણ એ કેમેસ્ટ્રીમાં હતું, ફિઝિક્સમાં તો, થર્મોડાયનેમિક્સમાં એવું બધું નહીં આવે કંઈ. ઓકે, એ ફલક આટલા જલ્દી પ્રોસેસીસ શું વાત કરે? હજી તો પ્રોસેસીસને તો બહુ વાર છે. પ્રોસેસીસ આજે કરાવી દઈશ તો કાલ થર્મોડાયનેમિક્સ પૂરું થઈ જશે. ઓકે, સો નાવ ધ નેક્સ્ટ થિંગ. હવે પેજ બદલવાનું. ઓકે, ધ નેક્સ્ટ થિંગ ઇઝ સાઇન કન્વેન્શન. આખું તમને લખાવી દઉં પહેલાં જ, પછી બધું સમજાવી દઈશ. ઓકે, સાઇન કન્વેન્શન ઓફ thermodynamics or in thermodynamics. Okay, so there are you could say 6 points. આમ તો 4 જ છે. પણ હું વધારે ડિટેલમાં લખાવું છું. ઓકે, સો ફર્સ્ટ વન, if heat is transferred from surroundings to system, that is heat is absorbed by the system. Okay, then what do we have? Then we have, અહીંયા હવે સાઈડમાં જગ્યા ઓછી રહી, then we have Q is greater than 0. Our first point. Clear? Okay, first point clear? એટલે 4 જણને સમજાણું આવું. Endothermic reaction, you could say that no. Endothermic તો ડેલ્ટા એચ ઉપર ડિસાઇડ ન કરવાનું હોય હે શ્રીમા કાવ્યા? Isn't endothermic based on delta H? Is delta H same as Q? Is delta H same as Q? I'm just asking you, everyone. હું તો ભૂલી ગયો, ફિઝિક્સમાં આપણે ડેલ્ટા એચ નથી આવતું, એટલે આવે એકચ્યુઅલી, પણ તમારા સિલેબસમાં નથી. Delta H is not same as Q, right? Only under some circumstances it is equal, and in other circumstances it is not. Okay. Call ઘનશ્યામ સર રેવા દો, પછી ડિબેટ થશે કેમેસ્ટ્રી ફિઝિક્સની. નંબર 2. Okay, number 2. If heat is transferred from system to surrounding, if heat is transferred from system to surroundings, okay, that is, we can say that heat is released by the system. Okay, heat is released by system. Then we have Q is less than 0. Okay, next, number 3. હવે આ આવડી જશે, બેની વચ્ચેનો કેસ. If no heat is exchanged between system and surroundings. Handwriting બગડે છે, ચાલશે ને? If no heat is exchanged between system and surrounding, right? That is, system neither absorbs, that is, heat is neither absorbed nor released. Agro word, expended. Heat is neither absorbed nor expended by the system. પણ આપણે રિલીઝ લખીએ, ચાલશે. Then you have Q equal to 0. બરાબર? આ 3 પોઈન્ટ સુધી તો બધા જલસા જ કરે, બરાબર ને? Okay, now point number 4 is about work. Now when we come to work, I want to explain the philosophy first of all before we get on to writing these. કારણ કે એક વખત philosophy સમજાવી દઈશ ને તો તમે આ જાતે લખી લેશો, મારી જરૂર નહીં પડે તો. Okay, so first of all, before we go to point number 4, let's understand for work. See, do you remember that work is nothing but transfer of energy? Yes or no? And this is typically done by forces, right? When the energy is transferred because of forces, we call it work. So heat kone kehvaय? Transfer of energy, but not by forces, but by difference of temperature. Okay, hopefully everyone remembers that, right? That is heat. ઉતાવળ નહીં કર નંદિની, પછી નહીં આવડે, બરાબર? Okay, So this is the basic idea. Now listen to this. In physics, we are always talking about energy as money. Do you remember? Do you remember? Energy is like money. So all we are doing in physics is we are keeping a watch on systems account. I repeat, physics માં બધું એક જ વસ્તુ ધ્યાનમાં રાખવાની છે. We are keeping a watch on systems account. Okay, listen to this carefully. We are keeping a watch on systems account. So if heat is transferred from outside to inside, that is from surrounding to system, this heat will be considered positive or negative. Look at the arrow. Positive or negative? System na account માં પૈસા આવ્યા. That means this heat is considered positive. Clear? Concept clear? Okay? Right. Now it is that ultimately when we study thermodynamics in physics, listen to this carefully, our aim is basically to understand what can system do for us. Listen to this carefully. What can system do for us? Okay, right? What can system do for us? Okay, so please be careful here. System આપણા માટે શું કરી શકે? That's the main thing, right? So keeping this sentence in mind, suppose you give system some heat and it will do some work for us. એટલે એણે આપણને work કરીને દીધું. You understand what I am drawing here? Okay, so because it has done something for us, we call it positive work. When system does work, be careful, when system does work, point number 4, work done by system, okay, that is considered positive, right? આ બે ની વચ્ચે છે ને એક લાઈન છોડજો. Okay, work done by the system is considered positive. Again, what's the idea here? કેમ આવું આપણે લઈએ છીએ? I know it is weird, but the philosophy is here, this one. By system, મેં અહીંયા જે લખ્યું છે એ જ, work done by system. I am not making a mistake. કેમેસ્ટ્રીમાં ઊંધું છે, યસ, હવે અહીંથી જ મજા ચાલુ થશે. ઓકે, વર્ક ડન બાય સિસ્ટમ, W is greater than 0. Be careful everyone, right? Work is done by the system, that is W greater than 0. આવું આવશે જ અને આવું થાય જ તે. કન્સેપ્ટ વર્ક ડનનો ઇક્વલ ન હોય. કન્સેપ્ટ કેમેસ્ટ્રીમાં તો તમારે વર્કનો કોઈ કન્સેપ્ટ જ નથી. આઈ વિલ બી વેરી બ્લન્ટ. તમારે ઘનશ્યામ સરને કહેવું હોય તો કહી દો, આઈ વિલ બી વેરી બ્લન્ટ. કેમેસ્ટ્રીમાં તમારે વર્કનો કોઈ કન્સેપ્ટ છે જ નહીં. વર્કનો કન્સેપ્ટ ફિઝિક્સમાંથી આવે છે, ડોન્ટ ફર્ગેટ. ઓકે, yeah, you will soon realize, okay, when we'll talk exactly about what is work done in thermodynamics, you will soon realize why it should be like this only. અને આ સાચું છે, it is reasonable. Okay, it is reasonable. હું તમને એક ચેપ્ટર 6 ની એનાલોજી આપું. ઓકે, હવે જેને ચેપ્ટર 6 યાદ હશે એને બરાબર સમજાશે, બાકીના જોવો ખાલી. સપોઝ there is a block here, suppose there is a block here, okay, and this is smooth surface. Suppose આ બ્લોક નો કંઈક માસ છે, no problem, and yeah fine, let me tell you the mass also. Suppose this mass is 1 kg, it's at rest, okay. Now you stand over here, right, okay, you stand over here and you push this by applying some force, okay, and as a result this starts to move and then you stop applying force. समझा कि नहीं? For some time you applied force, then you stopped applying force. So ultimately, because you applied force, it will get a velocity, right? So suppose from rest its speed increases and suppose the speed becomes 2 meter per second. Suppose the speed becomes 2 meter per second. હવે શું કહેવું? You applied force, correct or not? That's why this gained kinetic energy. Do you agree with me? That's why this gained kinetic energy. Yes or no? Acha, સરસ. So I'm going to ask you a simple question. Suppose someone studies you as a system, okay? Suppose someone studies you as a system, right? Okay, now so is it clear that you did the work or system did the work? Yes or no? The system did the work, yes or no? Very good. Okay, fine. System did the work, you did the work. અચ્છા, એ કેટલું વર્ક થયું હશે એ તમે ફાઇન્ડ કરી શકો ને સિમ્પલી બાય ડુઈંગ ડેલ્ટા કે હિયર, કારણ કે આમાં કંઈ બીજું છે નહીં. mg નોર્મલ ફોર્સ બધાનું વર્ક 0 આવશે. સો ધીસ ઇઝ ગોઈંગ ટુ બી હાફ એમ વી સ્ક્વેર માઇનસ 0 ઇનિશિયલ 0 થી. સો યુ ડીડ અ વર્ક 2 જૂલ, યસ ઓર નો? યુ ડીડ અ વર્ક 2 જૂલ, યસ ઓર નો? Okay, very good. You are system, you did a work 2 joule. Now I'm going to ask you your this question. એનાથી બધું જ ક્લિયર થઈ જાય. The question is, did you transfer, you that is system, okay, don't forget system એટલે you છે. Did you or did system transfer energy, that is give energy, did system give energy to others, means surroundings? Yes or no? Yes or no? Okay, so here what would you say? What would you say? Would you say system did work, system does work, or would you say work was done on system? Which one would you pick? Number 1, number 2? Number 1, number 2? System did work or work was done on the system? Very good. હવે વર્કની વેલ્યુ જોવો, પોઝિટિવ છે કે નેગેટિવ છે? 2 વાળા કેમ? વર્ક વોઝ ડન ઓન સિસ્ટમ, તમારી ઉપર બ્લોકે વર્ક કર્યું હતું. હે, જે લોકોએ સેકન્ડ સેન્ટેન્સ ચૂઝ કર્યો, આઈ હેવ ટુ આસ્ક યુ ધીસ ક્વેશ્ચન. બ્લોકે તમારી ઉપર વર્ક કર્યું કે તમે બ્લોક ઉપર વર્ક કર્યું? Who gave energy to whom? You gave energy to block. Simple. So do you see that when system does work, the work value is actually 2 joule, that is positive, not negative. Clear or not clear? Remember, this is work done by system. Okay, it is work done by the system. So that's why I was saying that it is natural. ખરેખર આ બરાબર જ છે. But don't worry, the chemistry one is not wrong. I'm not saying it is nonsense. It is okay, it is fine. એના માટે તમારે થોડોક વ્યૂ પોઈન્ટ બદલવો પડે. In chemistry, the viewpoint is reaction. Okay, the reaction is what is given more importance, and here we are not giving the reaction that much importance. Instead, we are giving this sentence importance. What can system do for us, right? Okay, fine. So in physics, I think it is natural that the work done by the system should be positive. એવું મેં તમને reason સમજાવ્યું why I think it is natural. Okay, એનાથી chemistry વાળું કંઈ ખોટું નથી થતું. That's why this is not called rules, it is called convention. Convention નો મતલબ બધા ઊંધું લે તોય ચાલે. હા, પણ મિક્સ નહીં કરવાનું. મને એવું યાદ છે. I clearly remember, you know, that I used to solve chemistry questions by using physics sign convention, even in chemistry paper. ઓકે, ખાલી લખવાનું ઊંધું એટલું યાદ રાખવાનું, બાકી મગજમાં તો બધું ફિઝિક્સની જેમ જ ચાલતું હતું. ઇટ્સ ઓકે, ઇટ વિલ ગીવ યુ ધ રાઇટ આન્સર એવરી ટાઈમ. Okay, because I find this much more natural, much more intuitive, right? Okay, તમે કહેશો તો હું તમને કેમેસ્ટ્રી વાળું સમજાવી દઉં, એમાં કંઈ મને વાંધો નથી. I will be able to explain it, but this is more natural in my opinion. Anyways, work done by system W greater than 0. Generally એવું થાય, generally volume of system increases. આ લખી લો. Generally volume of system increases. Okay, આ કેવી રીતે આવ્યું ને એ પછી આવશે. ઓકે, ડોન્ટ વરી અબાઉટ ધેટ, અત્યારે ખાલી લખાવી દઉં છું, સો યુ ગેટ અ ગુડ લિસ્ટ. Okay, so this is work done by system. We consider W, or we will get W greater than 0, right? Naturally એમ જ આવશે. Number 5, હવે આનાથી ઊંધું, એમાં કંઈ સમજાવીશ નહીં. Work done on the system, right, will be negative. That is whenever this happens, W on its own will be negative. You will not have to consider it negative, automatically it will be negative. સમજ પડે છે? Automatically it will be negative, right? આ ઓલા વેક્ટર જેવું છે, આમ જાય તો પોઝિટિવ જ હોય, આમ જાય તો ઊંધી બાજુ જાય તો નેગેટિવ જ હોય. That's okay, right? And in this case what will happen? Generally volume of system decreases. Generally volume of system decreases. This bracket is quite important. Okay, and number 6, no work is done. બધા નકામા છે. Okay, no work is done. Yes, that of course will give W equal to 0, and that would be generally volume of system remains constant. Does not change નહીં લખે કોઈ. Volume of system remains constant. I know you might be thinking, sir, આ બેમાં શું ફરક? You know, according to English there is no difference, but when you write does not change, then it's possible that you will develop a misconception. માઇન્ડમાં ને માઇન્ડમાં તમે એક કન્ફ્યુઝન પોતાના માટે ક્રિએટ કરી લેશો, અને પછી મારે ક્લેરિફિકેશન આપવું પડશે. ઓકે, એ सम्स આવશે ને ત્યારે ખબર પડશે. So generally volume of system remains constant when no work is done. So these are the 6 sentences that I want you to know. Okay, right? Fine. Let's go to okay, so let's go to the next thing. Now we are probably going to explore something that you don't like. Hormone equilibrium. Okay, thermal equilibrium or zeroth law of thermodynamics. કેમેસ્ટ્રીમાં આવે તમારે કે નથી આવતું? આવે જ ને? Thermal equilibrium or zeroth law of thermodynamics. Now this, why is it? તો હું એ શોર્ટમાં જ રાખીશ કારણ કે એનું બહુ સિમ્પલ આમ કોમન સેન્સ જેવું જ છે. ધીસ વોઝ ઇનફેક્ટ રિટન લેટર એટલે જ એનું નામ ઝીરોથ લો છે. પહેલાં ફર્સ્ટ લો ખબર પડી ગઈ પછી ખબર પડી લે આ એક બીજો બેઝિક સેન્ટેન્સ લખવો જોઈએ. દેટ્સ વાય ઝીરોથ લો. તો વોટ ડઝ ધીસ મીન? First of all, let me tell you what is the meaning of zeroth law. પછી સ્ટેટમેન્ટ તો ઠીક છે, તમને નહીં આવડે તો ચાલશે. કેમેસ્ટ્રીમાં કદાચ તમારા સ્ટેટમેન્ટ આવી જ ગયું હશે. Here we go. Suppose there are two bodies A and B. No, zeroth is not name of person. રોહન બાકી કંઈક નવું જ લાવ્યો. So A and B, and if they are separated by a diathermic wall, okay, if they are separated by a diathermic wall, right, and they are in equilibrium, and they are in thermal equilibrium. With thermal equilibrium નો મીનિંગ કોને આવડે છે? કેન યુ પ્લીઝ રાઇટ ઇટ ધેર ઇન ધ ચેટ બોક્સ? મને ખબર પડે સમજાવું કે ન સમજાવું. થર્મલ ઇક્વિલિબ્રિયમ નહીં કે લખો છો? એ કઈનું સાચું નથી પડ્યું હજી. કેમ આવું? there is one correct answer at least. Okay, so thermal equilibrium means following. I am writing it in yellow. Meaning of thermal equilibrium. હવે આ લો અડધો છોડો, પહેલા આ લખો. Thermal equilibrium means two bodies, if they are at same or equal temperature, if two bodies, if they are at equal temperature, okay, then we say that the bodies are in thermal equilibrium. બીજું કંઈ નહીં હો. This is the one and only true definition. Okay, this is the one and only true definition of thermal equilibrium. Two bodies, they are at equal temperature. That's it. Na, Ria, not correct. બીજું કંઈ નહીં. Temperature is constant એ નહીં. Nothing else. I repeat, nothing else will do. Every other definition is wrong. Only this is right. Temperature constant એ નહીં. Okay, only this, that two bodies must have same temperature, then they are in thermal equilibrium. આનું હું તમને રીઝન સમજાવું. ઘણીવાર કેવું થાય ખબર છે, તમે કેમેસ્ટ્રીમાં ભણી જ ગયા છો. સો આઈ એમ ગોઈંગ અહેડ ઓફ વોટ આઈ હેવ ટોટ યુ. If you understand, very good. If you don't, never mind. Sometimes we have adiabatic processes. In adiabatic processes, heat is not transferred. Do you understand what I am saying? In adiabatic processes, heat is not transferred. Then that does not mean that system and surroundings are in thermal equilibrium. I repeat, it does not mean that system and surroundings are in thermal equilibrium. Okay? So be careful. Only one thing is correct, that is two bodies must have same temperature, then they are in thermal equilibrium. પછી પાછળ જે થતું હોય એ બધું જે થાય no problem, but this is basic criteria. Okay, diya, so that can be costly, right? Temperature is equal and temperature is constant. They are two different properties. બરાબર ને? ચલો, coming back to this. So if A and B are separated by diathermic wall and they are in thermal equilibrium, okay, obviously if you leave them like that for long time with a diathermic wall, equilibrium માં આવી જશે. Okay, so their temperatures are now equal, right? Okay, now separately, okay, separately, that means in a different scenario or in a different situation, this same body B, if you pick it up from there and put it here, okay, and you put it with another body C, and you put it with another body C, and once again they are separated by diathermic wall, and still ultimately you see that B and C are also in thermal equilibrium. ઈજ તો વાત છે નંદિની. Even if this wall is diathermic, because they are in thermal equilibrium, nothing will happen. You understand what I am saying? Even if this wall is diathermic, because they are in thermal equilibrium, nothing will happen. આ કેના જેવું છે ખબર છે? નીચે ડ્રો કરું છું, પછી પાછા લો પર આવીએ. સપોઝ this is one vessel, એની અંદર water છે up to this level. It is connected by a small pipe with another identical vessel up to with water up to same level. તો બોલો આને ઇક્વિલિબ્રિયમ કહેવાય કે નહીં? Okay, is this a conducting pipe? Will water flow in this pipe? No. Can water flow? Yes. See, these questions are amazing, isn't it? Will water flow? No. Can water flow? Yes. I hope you understood the difference. So, can heat flow? Yes. Diathermic. Will it flow? No. સમજાણું? Yeah, so you see, if you put adiabatic walls, તો કઈ કરવાનો મતલબ જ નથી ને. Then B and C are not interacting with each other. You understand what I'm saying? Okay, so again, so we have that two bodies A and B are separated by diathermic wall. They are in thermal equilibrium. Similarly, separately B and C are also in thermal equilibrium. Then if you put A and C together, and you separate them once again by a diathermic wall, then A and C will also be, or are also in thermal equilibrium, right? This whole thing is zeroth law. તમને એવું થશે કે આવો કેવો લો, આનો શું મીનિંગ થતો હોય, right? Its meaning is amazingly simple. It is as follows: if A and B are in thermal equilibrium, that is only possible if TA and TB are equal. સમજાણું? Yes or no? Similarly, this is only possible if TB and TC are equal. Okay, and that obviously means this. Okay, so what does zeroth law say? Zeroth law says that અચ્છા આ બે ઇક્વલ છે એમ, અને આ બે ઇક્વલ છે, અચ્છા એમ, તો આ બે ઇક્વલ થશે. That is what zeroth law tells you. સમજી ગયા ને? છે ને જોરદાર. I hope you got it completely. It's a very simple idea, right? એટલે પહેલા તો લોકોને લાગ્યું હતું કે આવી વસ્તુને શું લો કેવો, એટલે એ લોકોએ કંઈ બહુ એને ઇમ્પોર્ટન્સ નહોતું દીધું. પછી ધીરે ધીરે એમને લાગ્યું કે ના, ધીસ ઇઝ ઓલ્સો અ વેરી ઇમ્પોર્ટન્ટ સેન્ટેન્સ. ઓકે, લોઝ તો બધા સેમ જ હોય દિયા, બધા લોઝના મિનિંગ ગમે ત્યાં ભણો તો સેમ જ થવા જોઈએ, અદરવાઇઝ ઇટ્સ નોટ કોલ્ડ અ લો એઝ સચ, રાઈટ? So that's the zeroth law of thermodynamics, which is very simple. Hopefully you understood it completely. Okay, I think that's enough for today. ઓલા સાઇન કન્વેન્શનના સેન્ટેન્સીસ ને બધું યાદ રાખજો. We will continue tomorrow, all right, with what is the exact definition of work. Then what's difference in chemistry and physics is work. Yes, but you know, the approach of studying is a lot different. In chemistry you have entropy and Gibbs free energy and all that in your syllabus, right? In physics we don't have those things in the syllabus. Instead the focus is more on work and different types of processes and engines and all that. Okay, right? ખાલી સિલેબસમાં અલગ છે, બાકી એવું નથી કે ફિઝિક્સમાં એવું બધું ન આવે. આગળ હાયર લેવલ ફિઝિક્સમાં થર્મોડાયનેમિક્સ કરો એટલે આવે જ છે. નંદિની, ફિઝિક્સમાં બહુ મોટો ચેપ્ટર છે પણ તમારી બુકમાં કંઈ આપ્યું નથી, 10-12 સમ આપીને પૂરું કરી નાખ્યું. તો વેન વી ગો ટુ નીટ એન્ડ JEE, ઇટ્સ લાઈક અ મોન્સ્ટર. ઓકે, આઈ એમ નોટ ટ્રાઇંગ ટુ સ્કેર એની વન, બટ દેટ્સ ધ ટ્રુથ. ઘણો મોટો ચેપ્ટર છે. ઓકે, ગુડ બાય.